This week we're going to go over first the quiz from last week, quiz 4, over the ethers and esters and multiple. Pardon? Yeah, I need to hand it back to you. That's right. Sorry about that. The high grade on the quiz this time was 100. Apparently, I put them over here. There was actually a couple of hundreds. Ben Spalding and Nathan Robertson. Good job, guys. But this is probably the highest average of all the tests by far, I think. There you go. Brian Ponner? Okay. Never. Is that how you pronounce your name? Ponner? Yeah. Okay. Get this. Corey, Sarah, Kristen, Jamal's not here, Sarah's not here, James. Okay. So, we rolling? Okay. The first problem there is what? What is that, first of all? What class is that? Ether. There's an ether, right? Because of this group here. R, O, and then R. The name of the molecule was p-cressyl methyl ether. The parent oil you could have put, well, you should have put ylang-ylang, or I accepted just ylang, either one. The chiral atom, there's no chiral atoms here. And the sample ID was number 9. Okay. This one obviously is what? Yes? Now, you have two that looked similar, right? You had this one and you had linaloyl acetate. And the way to remember the difference, the key difference, is that, you know, linaloyl acetate, which is this one, doesn't have any cis-trans isomers. So you look at this bond and you say, oh, there's no possibility because you have the same and the same on this end. So when you look back at nearyl, remember anything that's a nearyl is going to have a corresponding geranyl component. So this is your nearyl because the two big groups are on the same side of the double bond. So this is nearyl acetate. It's an ester. Parent oil would be helichrysum. Really not any other choice here for that one. We didn't discuss anything really. There are other oils that contain it, but helichrysum is by far the one that has the most, the highest level of it. Chiral atoms, no chiral atoms here. And the sample ID number was 5. That's probably, I would say, out of the group, that one there is probably your mildest smelling, right?
I wouldn't know that.
It's a subtle, it's a more subtle floral. Okay, next one there is benzyl acetate, right? That's pretty easy. I mean, if you've had even basic organic chemistry, you know, this is your benzyl, this is acetate, the acetate group, so you should be able to see that pretty easily. Class is an ester. Parent oil this time would have been either ylang-ylang or I would have accepted jasmine absolute. There are no chiral atoms here. And the sample ID was number 2. The next one there is what? Estragol. Estragol, remember, has the double bond on the tail. And then the other one that's very close is the anethol, which has the double bond right here. But this one is an ether. Parent oil would have been basil. There are others, but I don't know if we really talked about any others other than basil. There are no chiral atoms again on this one. And the sample ID was number 7. The next one is Eugenol. And the class there would have been what? Yeah, it's multifunctional, right? Because you've got an alcohol group here, you've got a phenol, if you look at this, you've got an ether. So there's several things going on here. Name the parent oil, you should have put either clove or cinnamon leaf. Not cinnamon bark, but cinnamon leaf would have been acceptable. Or I accepted, I think somebody put allspice. That was acceptable. That's a major component, allspice. And bay would have been another acceptable one. No chiral atoms again. And the sample ID was number 10. That brings us to our friend Methyl Salicylate, which is another multiclass, because we have a phenyl group here, or phenol, which is a subgroup of an alcohol, and then we have an ester group here. And the parent oil would have been either birch or wintergreen. Again, no chiral atoms. And the sample ID was number 6. Okay, this one here is anethol, very close in structure to the estragol. And the class is ether. The parent oil would have been either phenyl or anise oil or star anise. We talked about all of those. No chiral atoms, and the sample ID was number 4. Next we have Benzyl Acetate, which by the ending ATE we know is an ester. We also know it because of this functional group here. The parent oil would have been fir needle oil. Several different types of fir you could have put, but fir needle oil is all you needed. Chiral atoms. How many are there? How many? 3. Yeah. Right? There's an inherent asymmetry to this molecule because of this group. And if this group were not here, it would be symmetric and there would be no chirality. But if you could draw, you would draw the asterisk here, here, and here. Those 3 carbon atoms all have 4 distinctly different groups hanging off it. And the sample ID was number 3. Okay, next we have Linaloyl acetate. Class is an ester. Parent oil, I would have accepted clary sage or lavender. And the chiral atom, there is one, and that is right here. Right there. And the sample ID was number 4. And last but not least, we have our good friend 1,8-cineol, which the drawing is a bit skewed here, but this is a methyl group. These would have looked better to have a methyl group here and over here, but it kind of gets convoluted with, you know, everything behind it. So there is a plane of symmetry right through these 4 atoms. This one, this one, this one, and this one. There's a plane of symmetry. So each side is a mirror image, therefore there can be no chirality. Class of this is an ether. The parent oil would have been eucalyptus or rosemary. And the sample ID was number 3. Okay. Any questions over any of that before we move on to the exam today, or any questions over this or anything that you want to clarify over the entire semester so far before we take the exam?
That PEA?
Hmm?
You asked about the difference between the rose absolute and rose oil?
The difference between rose absolute and rose oil. Yes.
One thing that I just asked the class.
The absolute is solvent extracted, right? And the rose oil would be steam distilled. The chemical difference is what?
Absolute PEA.
The absolute has PEA, main component, which could be up to 75%. And the essential oil has what as its main component? If we're talking Bulgarian. Pardon? Citronellol, yes. Citronellol. And the reason for the difference is, remember what the reason for the difference is? Yeah. PEA is very water soluble, relatively speaking, to just about any other thing in essential oil chemistry, really. It's one of the most water soluble components. So when you steam distill the rose, you get the PEA coming out into the huge volume of water that this oil is sitting on top of, right? So that PEA is in the rose water more so than it is in the oil. Almost none of it is left in the oil. It may be a very tiny percent. But when you do the solvent extraction, you don't have this. You're just pulling out everything in the first phase with the hexane extraction, including the waxes. Then you evaporate that hexane off and you have your concrete. Then you extract that concrete with your ethanol. That ethanol pulls out the more polar oxygenated components, leaves the waxy stuff behind, and also everything, all those aromatic components are being pulled out, including the phenylethyl alcohol, which is a large percentage of what's in rose. So therefore the phenylethyl alcohol is the main component of the rose absolute. Okay? Any other points of clarification? No? Okay. Well, let's get started then. So shut the video down and be back in after the quiz.